This video addresses one issue that can be very confusing when you're doing trig in Algebra 2 or pre-calculus, and you are working with reciprocal trig ratios and you're solving for unknown angles using inverse trig. And so inverse trig and reciprocal trig ratios get mixed up a lot. And so let's quickly look back at our trig ratios. So if we have a triangle here, and we've got theta as our bottom angle there, we've got the opposite side, we've got the adjacent side, and we've got the hypotenuse. And so sine would be the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is opposite over adjacent. And so those are our three main trig ratios. But then reciprocal ratios, that's where we get into cosecant, secant, and cotangent. So we got cosecant, secant, and cotangent. These are the reciprocals. So cosecant, secant, and cotangent just reverse the ratio. So that becomes hypotenuse over opposite, and the hypotenuse over the adjacent, and the adjacent over the opposite. And so you could also look at that as cosecant then equals 1 divided by sine, and secant equals 1 divided by cosine, and cotangent equals 1 divided by tangent. So those are reciprocals. That's just changing the ratio and swapping or switching the numerator and the denominator. But you're still dealing with the ratio of two sides. Whereas inverse trig is written like this. So you've got inverse sine, inverse cosine, and inverse tangent. And this now changes what you're actually looking for. With the inverses, you're trying to find a missing angle. With the reciprocals, you're just switching what angle or what side you're looking at as the numerator versus the denominator. Whereas inverse, let's draw a triangle. So we've got the right triangle here. Let's say we're still solving for this angle. And we'll say that this opposite side is 15, and the hypotenuse is 27. And now we want to find this missing angle. So if we've got a reference angle here, we could do Pythagorean theorem to figure out the third side. So let's do that now. We'll go 27 squared minus 15 squared equals 504. And so then we've got the square root of 504 gives us 22.5. So that would be the adjacent side. And now we could then figure out the angle with sine with opposite over hypotenuse. We could do cosine with adjacent over hypotenuse. We could do tangent with opposite over adjacent. Let's use opposite and hypotenuse. So we would set this up as the sine of theta equals 15 over 27. So now we have the ratio, but what we don't have is the angle. So that means that 15 divided by 27 is 0.55. So sine of theta equals 0.55. We'll round it to 6. It's 0.555 repeated. So now we're going to do the inverse. So the inverse sine of 0.556 equals theta. So now we can actually do that here. So when we were doing secant, cosecant, and cotangent, we did 1 divided by sine. So if we had that ratio, we could divide that to get the ratio of cosecant, secant, and cotangent. Or we could take the hypotenuse and divide it by the opposite, and we flipped those, or the hypotenuse of the adjacent. Whereas this, we're using a completely different thing. We're using inverse. So that's where we use sine with that -1. So that's inverse sine of 0.556. That is going to give us the missing angle. So if we solve for that, we find that the angle is 33.8 degrees. And so now we've used the ratio that we know to find the angle that's missing. Whereas with reciprocal, it's flipping it, so you could still use those ratios to solve and get a missing angle. Let's take a look at the reciprocal now. So for this one, sine was 15 over 27. That was opposite over hypotenuse, and that was the 0.556. So we could do cosecant then, would be 27 over 15, which gives us 1.8. So that just flips the ratio. Now, the other thing you could do, since cosecant equals 1 divided by sine, that means we could do 1 divided by 0.556. And if we look at that here, 1 divided by 0.556 gives us 1.8. Or if we did 1 divided by sine, well, that's if we have the angle. So just know that reciprocals are flipping the ratios. You're changing what you're looking at as the numerator and denominator, whereas inverse, you're looking for an angle, which is when we use the calculator and use shift sine and shift cosine, shift tangent to calculate the inverse of that ratio we're given in order to find the missing angle. So hopefully that clears up some confusion when it comes to reciprocal trig ratios versus inverse trig to solve for an angle. Hopefully that helps, and if you enjoyed that, please subscribe to my channel and stay tuned for more videos.